Data Day Seattle 2016. We have a special guest. This is the first time I've met Juliet Hougland, who is a data scientist at Cloudera. Welcome.
Thank you for having me.
Yeah. So this is your first Data Day.
It is.
How's it been so far?
It's been really wonderful. I'm excited to be here, and a lot of the talks that I've seen have been very high quality, always really fun, a lot of great speakers here.
Awesome, yeah. There are some real home run hitters here. You know, when I think about some of the people I've interviewed and some of the topics they're discussing, it's just really good stuff. Maybe we'll see you at Data Day in Austin, and you're out of San Francisco, so some of the people are kind of like, oh, I can't wait to go to where it's sunny. So we have an exchange program where, data scientists from Seattle come to the Austin Data Day, and then vice versa. Yeah.
Give the Seattleites some heat.
Yeah, exactly.
Some good barbecue.
Yeah, barbecue, sunlight, and heat, and then the Austin folks come up for a little shade and coolness and coffee, maybe.
Yeah, coffee seems to motivate most things in Seattle. That makes sense.
Okay, yeah, awesome. And so Cloudera, that's a huge player. How long have you been with Cloudera?
I've been there getting close to 2 years now.
Okay.
But I've worked in the sort of satellites of Cloudera for quite some time. My first job out of grad school was actually at a company founded by the first engineer and one of the founders of Cloudera.
Wow.
Where we were building a real-time machine learning modeling platform on top of HBase.
Wow.
Yeah.
That's very cool.
And
yeah.
so I've been with and around Cloudera people for a long time. I had a huge amount of respect for the engineers there. I think there's just a bunch of great people, and so was sort of jumped on the chance to work with Josh Wills and his team.
Yeah, that is a great team. A lot of great people there. And you were the technical editor for Learning Spark with Hougland, is that right? Mm-hmm. Yeah. And so, how old is that book now? How long has it been?
I think Learning Spark came out maybe a year ago, maybe a year and a half.
Yeah.
Holden and I met through various Spark, or actually we met through social circles and realized we both worked in very similar projects, particularly around distributed computing.
Yeah.
And so she and I have had a few projects together. We worked on a very silly project called Sparkling Pandas, which is sort of back when there was only one data set abstraction in Spark, and the way that it was exposed through Python was a little clunky and hard to use, and so it was a fun experiment to try and put a different API around that. Yeah. And then I ended up working with her editing Learning Spark.
Yeah. And then you ended up both wearing sparkly dresses along with Michelle Casbon.
Yeah, there's about 5 or 6 of us actually. Sort of started once you start speaking at conferences, there tends to be a repeat circle of people that you get to know, and a lot of people that are involved in the data science community. Yeah. And one day some of us were having brunch together and decided it'd be really fun to wear matching outfits. So we luckily avoided I think one of the options was sort of a wrestling unitard, but decided gold dresses was maybe a little more fun.
Okay. Yeah. So how about this? How about the guys do wrestling unitards?
We invited some of the men to wear gold dresses, and none of them really bought into the spirit of the event. But to each their own. Yeah.
And it's hard for guys sometimes to break out of the standard uniform, as I discussed with Hougland, which is a vendor T-shirt and jeans.
Yeah, absolutely.
So.
Well, and it's sort of interesting for a woman in tech. You sort of stand out quite a bit already. Yeah. And so it's really fun to just sort of play that up.
Yeah, definitely. Yeah, I dig it. Yeah, and also vendors, if you're smart, what you'll do is think about producing a gold sparkly vendor shirt, right? This could be the start of something new and exciting.
Those would fly off the shelves because I would take all of them.
Okay. Yeah, and then you would be set for the year. Yeah. So awesome. So Juliet, tell us, is there any cool, neat projects that you're working on right now you're excited about?
Yeah, so I'm perpetually excited about improving the state of Python on Hadoop and the state of doing data science across really large data sets. My first experience doing data processing on large data sets involved MapReduce, which is incredibly reliable but verbose and sort of challenging to begin to get at more complex tools. Over the last few years, I've started educating myself more about the Python stack and all of the sort of useful tools that exist there. And I've been trying to bridge the gap between the two. My technical experience definitely started on the distributed data side. And I'm now trying to pick up the Python side and connect those two. So, at Cloudera, one of the things that I helped with was an integration with a partner of ours, Continuum Analytics, which allows Cloudera customers to really easily install Anaconda across their cluster, because an issue with trying to use Python at scale is that it's a runtime environment, and you actually need that environment installed in each node of your cluster. And so the sort of logistical orchestration of even getting all the libraries that you would want to use, and as part of the usefulness of having Python out there, was challenging. And that's one of those things that Cloudera can really help with, and now it does. And so there's a team that I'm working closely with, the data science tools team, which Wes McKinney is on, and he is working very hard on a lot of really interesting projects around making Python and the normal Python data stack fit in better with Hadoop and CDH in particular. And so I find myself, I don't work on the engineering of those tools, but I use them a lot and sort of develop best practices around them. And Wes is always gets excited. He's like, I think you write the longest IBIS scripts. So IBIS is a project of his, which is sort of a logical extension from Pandas, where you can write what gets compiled down to SQL, but is relatively nice, clean, functional Python code, in which you describe the sort of operations you want to do on your data sets. It compiles to SQL and then can go execute against a database. And in my case, that database tends to be Impala. And so you can write these Python scripts, then go execute on a cluster and do something useful for you and return it back. And for me, I'm terrible at SQL. It's like it gets really complicated really fast if you're doing something even remotely complex.
Right.
Nested SQL ends up looking really challenging to me. And so I've really taken to using IBIS and using that in order to write something that's testable, reusable.
Yeah.
Write unit tests around it, which I have no idea how to do with SQL.
So, one more thing I wanted to ask you about was, and I read commercial applications of data science, including development of predictive maintenance models for oil and gas pipelines. Is that a project that's still in the works? Is something that's sort of buried and done?
So that project is a little buried and done. That was the second startup that I worked at. I was the first employee, first engineer there. And we were trying to figure out a good product that's very consumable for oil and gas pipeline maintainers. And their core problem is they don't want to spill oil and gas everywhere.
That's a good, it's a good concern.
Admirable.
Yeah, definitely.
And so they have a lot of data around where the pipelines are, what they're buried in. They have regular sensor data where they send these things called pigs. They're not actual pigs, but
and not pigs in the big data sense.
Yeah.
Right.
So heavily instrumented sort of sensor tubes through the pipes.
Okay.
And they want to understand where to best spend their maintenance money to prevent spills.
Okay.
And so this gets into the question of, you might not be able to predict where a spill will happen, but you can probably find a good way to allocate money effectively for maintenance so that you're looking at high-risk areas. And so that was actually my first introduction to hazard models and risk analysis, which is a topic I'm going to be talking about in my day-to-day Seattle talk.
Oh, nice.
Because I realized that it's a very useful technique, and it's not as widely used as I think it could be. And so my day-to-day Seattle talk is actually about observational methods and interesting applications of them. And currently, so I was working on this sort of customer-facing Cloudera data science team. And I recently moved into working for doing data science just for the engineering team internally, asking questions about how Cloudera's engineering is working. And so the question that I was posed is our software good? Is it getting better? Can we quantify this?
Okay.
And that's legitimately amorphous and hard problem to try to address. But if you look at risks and hazards, you can look at aggregate risks and hazards across all of our customers and the information we gather from our customers to try and assess whether or not we're making good software or not. Is it risky to our customers or not?
Yeah. That's fascinating. Yeah, I didn't think about that. It's like when I think about risk mitigation, I think about, like you said, oil pipelines. I saw one recently where they were being used under manholes. Like you could predict manhole cover explosions. And I forget what city it was. Maybe it was in London or something like that. And they wrote some code to figure out. They knew which manholes were going to explode because of gas buildup and rats chewing through wires and so. But I never think about risk mitigation, like you said, internally from a company. Like, okay, can we predict what our trajectory is? Are we doing better, or are we not doing better?
Yeah. And it's a really fundamental question. I think when I pose it to most engineers, they're like, "Oh no, you're going to start counting lines of code at it or something, aren't you?" No. It's really practical risk. Like, are our customers calling us for help because their product's broken or not?
Yeah. Well, fascinating stuff. Juliet, it was a pleasure to meet you. Thanks for coming. I hope you continue to enjoy the show. Maybe we'll see you at another one coming up. And yeah, we look forward to keeping up with you and finding out what's going on at Cloudera.
Thanks. It was very nice talking with you.
All right, take care.